Okay. Hello, everybody. Hello. Wow. Hello. How's everybody doing today? Alrighty. There we go. Now we got it. How's everybody doing today? Hopefully you're all doing really well. Doing awesome. How are you? I'm doing really well, Ivan. I'm doing really well. I gotta know, you sound like in a really upbeat mood. What happened? I'd like to hear the good news. Oh, that's okay. There we go. We'll start here in a few minutes. We'll wait for a few more people to come on by, and we'll get going. Hey, Gustavo, how are you? I hope you're doing okay. Hey, Diego. I'm doing pretty good, Diego. It's been all good. Put that away. Did your homework up to chapter 7? Nice. All right. So far, so good. Getting caught up. Very good. Very good. Now, that's really good to hear. Get your stuff caught up and, start to get going there. It's all good. Got a little bit of ways to go, so glad you're in the 16-week class. Yeah, you got lots and lots of time. We're not even halfway through the semester, so you got a ton of time and a lot of you get up, just sit back, relax, and have a little fun. Hey, Miguel, how are you? Looks like we got the Looks like we got a lot of regulars. It's good. All right. Almost ready to go here. Yeah, everybody's in a good mood today. This is a good. I like it. 16-week gang. Yeah, the aha moment when doing the vernier calipers question. Oh, okay, that's good. Hey, it's Owl. Hello, how are you? Oh, okay. Well, I apologize if my explanation wasn't that great. That's fair to say, Gustavo. I ain't gonna blame you. Didn't understand the pictures. Okay. Well, like I said, just hope that I know sometimes my explanations don't always go through, but I try and keep it as clear as I can. It all happens. No problem, no problem. All right. Okay. Let's go ahead and get started here with some 097. I think it's time. All right, let's do it. Okay, let's get started today. Welcome back to Monday. Hopefully everybody had a nice weekend. All right, so for today we are going to be moving on here in chapter 7 of the textbook. All right, and we will also be talking about, again, a little bit of chapter 8, talking about geometry and whatnot. So, well, not geometry, but more along the line of, well, plane geometry, like 2D shapes and whatnot. Okay, and then we'll talk about 3D shapes in the next chapter after that. So, okay, in any case, let's go ahead and we're going to move forward here. Last time we talked a lot about algebra, talked about the basics of algebra. We talked about how to do one-step, two-step problems. Okay, we discussed about how to do that. Now we're going to take that same concept that we talked about last time, and we're going to be able to apply it to some other types of word problems. Only in this case, we're going to be a little bit more abstract than we were previously. So let's talk about how we can do that. Now, one of the things that we did discuss here specifically was we did discuss again, remember, the key to all algebra, which is the easy, well, hopefully we understand the key to algebra. Actually, why don't you guys tell me, what did you guys learn last time? What was the key to algebra? What did we get there? What's the key to algebra? Oh, why is this always 11? Hey, stop. What's the key to algebra that we talked about last time? That is correct. The key to algebra is always balance. That's right. Balance is your friend, right? We know balance, we know how to do these problems, all right? That's pretty much how it's going to go in this section as much as it was in the first 4 sections. Okay, So what we're going to do here is we're going to look at we'll look at one basic problem, and then we're going to see how balance works in a little bit more of an abstract way. All right, so as you can see here, in this particular case, we have some equations. We want to solve for a particular letter. We want to get a letter by itself and then be able to solve for our final result, whatever it may be. I'm just going to take a couple of examples here that not make it too hard. So I'll do that one since it's there. Okay, so we have 22n equals 16n minus 18. And our goal here is just to solve for n. Yeah. All right, so if we're going to solve for n here, what do we do first? We're going to get n by itself. So what do you think? Oh, is that still on? Why? I thought I turned you off. There we go. All right, we're going to go ahead and we're going to add 16. Add 16? Not quite. Remember, this is 16n here. Yeah, so this is plus 16n here. So we want to subtract by 16n on both sides, okay? Because we want to get rid of the 16n on the right side and move it with the other n's on the left-hand side here. So we have minus 16n, just like so. Then we could just do 22n minus 16n, which is 6n. We talked about like terms last time. And don't forget the sign here for this one. You had a minus sign here with an 18. So we have minus 18 just like so. All right. Any questions so far? Hopefully that straightforward there. Nope. All right, what's the next step then? What do you do next? What is our next step? Divide both sides by 6. All right, that sounds good. All right. And so here we're going to get n is going to equal negative 18 divided by 6. What do we get? Minus 3. Good. Spot on. All right. So by itself, that type of problem here isn't too hard. It's just, again, taking our same balanced approach as we had from before and just pretty much going ahead and solving for whatever letter that we need to solve for, in this case, n. Okay, so that's all well and good. That's fine. All right, fair enough. Now, let's go and bust out the next example here. This one I will need the paint tool for, so yes, that's good. All right, so the big key here in this section is how do we make this more abstract? Well, let's take a look at one of those set examples of making this more abstract than we need here. So, okay, there we go. I'm gonna pick that. Okay, so in this case here, now we have lots of letters, okay? So now we got a bunch of letters here, and we want to go ahead and solve, in this case, for capital D. All right, so our goal here is to go ahead and get D by itself. Now, the thing is that this isn't like the last example where we had n is equal to, something. that we had n is equal to a number. In this case, we just have a bunch. We do have one number and two, but we got other letters floating around as well. Let's talk about the key behind this problem, though, and the key here is actually fairly straightforward. The key here is actually do not do anything different. Now, people think that there's something different between this problem and the last one where we actually solved for a letter and got a number back. What I'm trying to tell you is that there's no difference between that last example and this example. Absolutely none whatsoever. Your final answer may contain other numbers, but the process of getting to that point is exactly the same as we had for the last problem. There is absolutely no difference. So if you think just because we got extra letters and all this other stuff kind of thrown in, and you think that it magically changes the entire process, the answer actually is no. The approach here is exactly the same as you would if I just changed changed R to a random number for all I know. All right. So if you think of it that way, just imagine, if you will, you think of it that way. Well, if I want to get, D is equal to something, then let's take a look here at this one. We have, what do you think we should do first if we want to get D by itself? Okay, that's right, Miguel. So let's go ahead and multiply by 2 on both sides. Ooh, I'll put that in red. All right, so we're going to multiply by 2 on both sides, so that's fine. Okay, so that's perfectly fine. So far we have 2h equals, and these 2's will cancel, so that leaves me with D minus R. Okay. All right, now what? Okay. Okay, that's right. We just want to get D by itself, so that's exactly correct. We want to go ahead and add R to both sides. Spot on. So let's go ahead and add R here and add R here. Now, they're not like terms. We really can't do much with them whatsoever. But at the end of the day, we're going to have 2h plus R equals capital D. And there we go. So all three of you are spot on here. All right. Definitely true. And you can see that our final answer here does contain some letters, but the process of how we got to that point doesn't actually change at all compared to what we did in the last example with numbers thrown in there. And that's pretty much all you have to do. Like, in all honesty, that's all you have to do. It's actually not as complicated as sometimes it makes it look out to be. But in reality, and in reality, it isn't. It's still the same type of problem with the same type of stuff and the same type of algebra. Questions about that before we move forward? Okay. All right. Easy peasy. All right. Let's go ahead and take a look here at take a good look here at several word problems. All right. So word problems time, because we're gonna probably do some of these other types of problems anyway. So let's go to the book here again. All right. Okay. So which one did I want to do again? No, not that one. Oh, I do that one. Yeah, that's fine. All right. So let's look at number 2, and I'll make this a bit bigger here. All right. So number 2, sheet metal trades. So the area of the sector shown in problem 1, that's the area of this sector of a circle, um, is A is equal to pi times r squared A over 360. Okay, where r is the radius and A is going to be um, the angle, the central angle here. In any case, let's take a look here at letter A. We want to solve this formula for little a. Now, this concept here, by the way, for the area of a sector or circle, we will see actually later on here, and I believe that's in chapter 9. So this will be another thing here. So if you want to figure out the area of, say, a pizza slice, you can actually do that. So in any case, let's go ahead and see what we can do with this. Okay, so let's put down the, so you guys are going to guide me for this one. A here equals pi times r squared little a over 360. And we have to solve for a, little a. All right, you guys. So what do I do first? What should we do first? I would solve exponents first, but I'm not plugging anything in for r. We're actually just solving for the variable. If I need to plug in numbers here in the exponents, then that I would do first, most definitely. But here we're just being abstract, so we're just trying to get those roadblocks out of the way. So we will multiply by 360. All right, so I got 360a is equal to pi r squared little a. Okay, what's next? What could we do next? We're trying to solve for little a. Okay, we divide by pi. What else can you divide by? There are two things you can divide by. I agree with that. You divide by pi. What else? The r squared. Right. So you could divide by both at the same time. That's perfectly fine. That's not a big deal. You could do it one step at a time, or the same time is also acceptable. Right. So here we have pi r squared, and we're just going to divide that on both sides. So this will cancel out, and that leaves us with little a, 360 capital A divided by pi r squared. All right. And that's it. That's how we solve for the first part here anyway. That's how we solve for little a. Okay, and then once you solve for that, it asks you to do to use the formula. So most of these problems here is they'll give you this, and they'll ask you to solve for one of the letters, one of the variables, and then it may just ask you to plop in some numbers and see what you get from the original formula. Some of them are like that. So for example here, if did this out here. All right, so basically the second part here is to find capital A, and they give us some random numbers here. They give us R here is equal to 12, and little a here is 45 degrees, and pi is 3.14, though again, I don't really use that. So if we want to we just plop those numbers in. So a is equal to pi times 12 squared times 45 all over 360. Okay, and then we go ahead and plug that into the calculator. Can anybody tell me what they got? If you got that in your calculator there. What do we get? All right. Nice. That is correct. Good. So that is our final answer here, 56.545487. We'll just go there. There we go. All right. 57 if we're rounding up, but go to the exact answer there. Much more important for exactness. So we're good. All right. Good. That wasn't too bad. I think those are relatively straightforward. All right. Use your calculator correctly. I approve of everything. All right. I like it. It is good. Okay. Let's go ahead and do one more from this section. And let's see what's going on. Nice job, Gustavo. All right. All right. Let's look at number 12. Number 12, automotive trades. The compression ratio R of a cylinder in a diesel engine given by R equals S plus C over C, where S is the swept volume of the cylinder and C is the clearance volume of the cylinder. Okay, solve for capital S and then find the swept volume if the clearance volume is 6.46 cubic inches and the compression ratio is 17.4 to 1. Okay, so let's go ahead and do this problem out. Okay. So first and foremost, let's go ahead and write in our problem. Okay, so we got to solve for S. That's what we got to do. So we got to solve for S. All right. So if we're going to solve for X, not X. No, X is later. Okay. Solve for S. All right. If we solve for S, what is what do we do first if we're going to try and solve for capital S? Divide with C. Now, technically, you could split it up here, but dividing with C would make it a little bit tougher. Multiply by C. Yeah, there we go. Nice. I totally agree with that part. Yeah. All right. So we got C here on the bottom. That's our first roadblock. So we need to get rid of that. So we multiply by C to get rid of that roadblock. But of course, balance requires us to do it on the left-hand side as well. Okay, so this is what we're left up with, where our CR is equal to S plus C. Okay, what's the next step here? We're trying to get S by itself. Okay, good. Get that C out of there. There you go. There, I agree with that. So subtract that C. Of course, do that to the other side. Everything is a balance in algebra, so we're just going to approach it the same way. So you got CR minus C is equal to S. There's a lot of things you can start with the letter C, but I think I know which one. Pronto. That's that. And that was the story. Oh man. All right. All right. So the next one here. I'm sorry, question mark. Let me do the let me do the second part of the problem before I give you any more ideas. Oh my goodness. All right. Okay, so we find the swept volume of the clearance is 6.46, which is S. So again, just reading off the context of the problem is important. So S here is 6.46, and C, the clearance volume here. C, the clearance volume here, we don't know, and A is the compression ratio, which in this case, yes. So compression ratio. Oh, R. Sorry, not A. My apologies. I'm doing two things at once. R is going to be 17.4. All right. So since we solve for, since we're trying to find the, since we know what C is, and oh, find the swept volume. Sorry, I got that backwards. Why? Why have I done it? Play that song for Diego. Hang on, I got a song for you, Diego. All right, I got a song for you. I got just the song for you, bro. Here we go. I'm just gonna play a little bit. Oh my goodness. That's too funny. Holy cow. I'm sure that gave you startling reminders. I'm sure. Look, Adele got nothing on Lionel Richie, man. Lionel Richie. There you go. Lionel Richie is pretty legit. Lionel Richie's got the. Lionel Richie's pretty legit. Gotta say Lionel Richie. There you go. That's right. That hair, man. Can't go wrong with the perm. Yeah. All right, I gotta. All right, I gotta finish this problem. All right, let me finish this problem. Okay, I gotta get there. Okay, that's just for you, Diego. Just for you, buddy. Uh, let's go ahead and wrap this problem up here. We got 6.46 and 17.4. Go ahead and quickly figure this out here. Just using our calculator here. And we get 105.944. All right, cool. All right, that's what we get for that problem. All right, questions about questions about that. All right, no questions then. We'll go. We'll move on. We're gonna we're gonna try and move on. I'm gonna try and get it together. All right, we'll try our best. Yes. All right. We'll do that. Okay. So the next section here talks about specifically section 7.7. Section 7.7 talks specifically about word problems. Okay. So word problems is going to be definitely one of those. I'm trying to move on. I'm sorry. Word problems is definitely one of those things that we talk about. We've talked about quite a bit here, pretty much in every single section for the most part. And what all we're doing here in this section is just being able to just do the interpretation part, and then you know then we can do that calculation. So we want to translate the word problem into an algebraic expression, and then going ahead and solving for it. Now we've been doing this quite a bit, but now with a lot more variables possibly thrown into play, then we were like, okay, how do we essentially can set up that? So we'll look at a couple of these problems here, and we'll see exactly how it works. All right. So let us do. Yeah, they'll do that. Actually, is that the one I want to do? Yeah, actually, let's do it this way. Let's go to 497. Don't worry, Diego. Don't worry. You'll find another. If it makes you feel better, Diego. If it makes you feel better, Diego, I'm on a 5 to 6 year losing streak. So there you go. Right on, bro. All right. Let's go ahead and which one I think I want to do here. All right. Okay, let's take a look at number 18. Okay, let's look at 18. Hi, Shaq. Hi, man. You're doing great work. Love to see you. I have to bottle flip? So what? You want me to bottle flip? Yeah, I got a bottle of medicine. Does that count as something, Shaq? I don't know. Here. I don't need $100, but sure. Let's see if I get it. I kind of don't really have a camera for showing a bottle flip, but whatever. See. No, I got to miss that one. Let's see if I get it again. Actually, how about if you? All right, I got a better idea. Rather than me bottle flip for $100, I got a better idea, Shaq. How about you give that $100 to a local animal shelter as a donation? I would if you that it would go better to a person. It would go better to animals who cannot take care of themselves. Please give the $100 to a local animal shelter. That'd be great. I don't need $100. I'm fine with what I got, but I don't need to flip no bottle. If please, $100. Yeah, let's make that work. I don't need $100, but those animals do. Please, you find a local animal shelter in your area, and then please just go ahead and donate that $100. I'll be very happy. Hell, I'll even match that $100 depending on wherever you send it. So you tell me where you sent it, and I'll match that same $100. All you have to do is just message me, Shaq. It's all good, bro. It's at least it'll go to a better place than me. No, 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 man. You donate 200 for the both of us? No, 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 no. We got to do it right. We got to do it right. We got to do it right. All right, Shaq, listen to me, my friend. Listen to me, my friend. Okay? If if you donate if you donate $200, then I will donate $500 to the animal shelter of your choice. You just tell me which animal shelter, and I will directly give them $500. I'm not hurting for cash, but animals need to be taken care of. Okay, if you're doing 1,000, I'll match that 1,000. I don't think I can go more than that, but still. Yeah, send me over in a whisper what animal shelter you donated to, and I'm down with that, bro. I'm totally down with that. I have to make sure it's not a scam. Yeah, that's why I want the animal shelter because I'll go to their website, I'll donate directly to them, I'll show you the receipts. I have no problems doing that whatsoever. I always think everybody should see receipts. So, I want to keep things transparent as best as possible. Now, prove it to these students here. I don't have a problem doing that. Professor for ruler of the world. I don't think I'll rule the world. Trusting my word isn't good enough, Ivan. Actions, my friend, actions. I should show you the receipt if I decide to, depending on what animal shelter they decide to donate to. I know, I know, and I appreciate your trust. I really do. But I still like to be transparent, so that way I'm always on the up and up. Oh, yeah. Hang on, let me make you moderator. Hang on, Shaq. Sorry about that. Here you go. You can now post a link, Shaq. Sorry about that. That's my bad. Let's take a look. Da, 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 da. I need English. English to donate. All right. Okay. Hang on a second, guys. I'm gonna show you the. Hang on. I'm gonna show you what Shaq has posted here. Um. Actually, I think that's the same thing, right? Let me check. Yeah, just take the English link here. See if probably is the same thing. All right. So here's the English link that Shaq has kindly given to us here. Okay. So we're gonna make a one-off donation here, and you said this is in the Netherlands, right? So I don't care if it's in the Netherlands. That's fine. Man, this is cool. They offer boarding services for rabbits and rodents and tame birds. Look at that. That's pretty awesome. Provide education, awareness, and facilitate social participation. Okay, that's pretty legit. All right, and they have a lot of strays, relinquished animals from the area. All right, so looks like it covers a pretty large portion of the area. Okay, that's perfectly fine. All right, and go ahead and. Is it okay if we can record your stream to share on your platform? Absolutely, please. You definitely have my permission. I don't mind what you do with it. Hopefully, I know it's a math class, but I'm more than happy to add to a worthy amount here. Let's see. I wonder if I could make more than just they can. So I got one question, Shaq. How can I make the full donation? Because it says I can only make 150 pounds or 150 euros. Sorry. So I want to be sure that I'm doing the right thing here. But so I'm just kind of a little confused where I should be doing the things. Just let me know about where I can go ahead and okay. I want to be able to just send it all in one chunk, so because it says like 150, but oh, okay. I see. All right, ladies and gentlemen. He has been very kind to send me a link here for the Stephen Schage Animal Shelter. And I will actually, I don't know what it is in euros. Yeah, screw it. I'll just put 1,000 euros. All right. All right. Cool. I'm gonna put some personal information. Is it okay that I put a? Is it okay that I put a address? Address like a U.S. address? Actually, that's pretty high. That's higher than I thought. That's 850? Oh, okay. I guess we'll do it that way. Wow, that was higher than I thought. All right. Yeah, let's do that then. Sorry, guys. I apologize for the delay. No, 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 no. Just had this a second ago. Bah. Oh, that's why. Yeah, that'd be a thing. All right, let me put 850 here. Actually, yeah, that'd be approximately $1,000. So let's see. Oh, that's my mod thing. Sorry. Doing one thing is hard, but so that's me. Just do this. There we go. No, sorry about that. Not now. All right, let's try this again. Let's try this again. I'm gonna try this again. Is he real? Am I real? I'm real. Let's see here. What the? How come I can't type that in? What? Oh, well, that would explain that. You said it was okay? Yes, I am. My platform I can't share right now. I have to ask permission from me. I mean, yeah, it's okay. I don't mind. I'm gonna have a hard time doing this, so I can't read. This is actually a little difficult. Um, no, no, that's not where I want to go. Hang on a sec. I wish this was made a little bit easier. Apologies, everybody. This is kind of taking a while longer than I thought it would take. So, okay. So they took me to a site, and I know this is I'm a little awkward at doing certain things, so this is probably one of them that I'm really bad at. This is definitely one of the things I'm bad at. Am I able to see your chat? Yeah, I see your chat there. I'm just trying to get into I'm just trying to get to the proper way I can pay, because I can't pay like the issue that I have is that I can't like um I have to like if they have it like an overseas way of doing it, you know what I'm saying? Like I want to do it. Yeah, this is I'm not obviously I'm not Dutch. I'm not Dutch at all. uh it's one of those things where I kind of wish I was Dutch right now and be like, okay, okay, bro, let's do it. Um, okay, let me go back here again. All right, guys, I'm gonna get this. I'm gonna get this. All right, we're going to go. We're gonna sign. We're gonna be a sponsor. Okay, that's what it was. And you do a one-off, and then I do this, and then I do my things. Okay, okay, I can do things anonymously. Oh wait, that's anonymous. Okay, I got it. So that's anonymously, but then the open donation is not anonymous. Okay. So then I do this, and then I do this, and where is the other thing? Oh, actually, this was the, okay, hang on. This was the wrong one. This is the right one. And then this is the, that's not it. And that's not it. And that's my mod window. Okay. And then this has to go over here. And you say it looks legit, as in yes. I mean, I would like to give it to you here, but I can't read this, so I don't know what this is. Although I know ING, I know that's a famous Dutch company. Yeah, that's probably a good idea. I agree with that. Shaq, do you think I can give you, I'm going to whisper you something, okay? I'll give you my email, and then you can, that's a good idea, guys. Yeah, I've taken a lot of time here, so let me go ahead and whisper you there, buddy. So, accidentally got out of that. Sorry about that. Let's go whisper here. My email. Okay, so I sent you my email there, uh, Shaq, and we can talk about it a little later. Uh, so that should be okay. So we could talk about it a little later, and then we could see what we could do to facilitate a transfer of some kind. But I don't want to take away any more time from these guys because they've been waiting for me very patiently. So I'm just gonna take off your mod there, Shaq, so I can get you back there. There we go. Okay, I just unmodded you. That's all. Okay. Thanks for the help, everybody. I really appreciate that. Hopefully you'll get back to me. Hey, thanks, Shaq. I appreciate you. Let's hope to talk to you soon. Thanks again. Okay, sorry for the delay, everybody. All right. We're going to go ahead and do a couple of these word problems here. All right, so let's go ahead and do here number 18. Okay, so number 18 says uh, trades management. Okay, yeah, yeah, that's true. Okay, so let's do number 18 here. That's what we got to do next. All right, so trades management. Four partners, four partners in the plumbing business decide to sell the business. Based on their initial investments, Al will receive 5 shares of the selling price. Bob will share 3 shares, and Cody and Dave will each receive 2 shares each. If the business sells for $840,000, how much is each share worth? All right. So, how would we set up this particular problem here for number 18? What do you think we could do? How could we set this up here? The business sells for $840,000. Now, there is a trick to this here. How many shares are there between all 4 of the partners? All right, 840,000 divided by 12. That's correct. Right. So let's go ahead and do that right now. Break into equal amounts, that's correct. Okay, so let's, where is it? There it is. Um, so let's do 840 divided by 12. Okay, so that's the first part of our process here. 840,000 divided by 12. Okay. Low key, that'd be pretty. That'd be pretty funny. Low key, that'd be pretty funny. $70,000. All right. Now, what would we do with that 70,000 based on the based on our problem here? Multiply the number of each person's share. That's right. So Al's receiving 5 shares. So how much is Al receiving if he receives 5 shares? So Al receives 5 times, I didn't want to put times there. 5 times 70,000. Hmm. All right, 350K is correct. All right, let's see. Bob receives 3 shares. So Bob gets 3 shares. Cody and Dave get 2 shares. Okay. All right, Ivan thought so. All right, who else? Fake AF, all right. Anyone else? Okay. I see. Quote unquote legit. Okay. That's fair to say. That's fair to say. Yeah. All right. No, thanks for guys. You guys are looking out for me. So okay. You know what? You're right. Maybe I got caught up in that, but you guys were looking out for me. So yeah, I should probably do the research before doing anything. I don't know. He may or may not be real. I mean, I don't know, but yeah, better to be cautious, right? Yeah, though that seems really fast that they how they donated that, right? Yeah. I mean, I see where you're coming from on that. Didn't sound real fishy when he said, I have to ask permission from me, when he had clearly told him that it was okay to share us. Oh, well, I appreciate that. Well, I'm still going to donate money, so that ain't going to change. I'm still going to donate money. That won't change. Even if I don't receive any email from him at all, I'll still donate the money. You guys are welcome to donate if you want. Right on, dude. Much love. How you doing, Bejewel? Oh, you're Steph. Hey, I hope you're doing okay. We weren't sure if that last guy, that Shaq guy, was a scam or not. That's what we were kind of talking about there. But since you're ready to do some math, my friend, let's go ahead and do some math. All right. Well, you got maths. No, no. It's not your fault, man. It's not your fault at all. I could totally understand that. I was going to donate some money to the local animal shelter, and some of my other students were going to be like, "Yeah, uh, they'll donate to the local animal shelter." If you want to donate to your local animal shelter, that'd be awesome too. Hey, we just want to keep, we want to keep a nice, safe environment for everyone. So I'm glad that these guys looked out for me as much as I'm looking out for them. Yeah, you should thank my students, not me. You should thank them. They're and everybody else in here. It's you know, we try. I know you guys try and keep as safe an environment as you possibly can on Twitch, and it's actions from both sides that really help create and foster a good community and a safe one at that. So, like, I'm really thankful. Like, to be perfectly honest, Bijul, I'm really thankful that I have this platform to really help out all these guys. So, I mean, without the platform, I don't think I could be as flexible teaching as I am now. So, I really have to thank you guys for that. Oh, no, Bijul's not from a different course. Bijul's part of the staff here at Twitch. He works behind the scenes. Oh, yeah, I guess this is our I guess this is our kind of I guess this is our kind of corner of the internet. Usual. I guess this is our kind of corner of the internet to educate as many people as possible. Um, you know, I don't do this for, to be perfectly honest, I don't do this for the donations or money. I barely get any of that anyway. But no, I do it for helping out my kids. So helping out the students that I got to teach for my classes. So I think that's what makes it fun and exciting. That, and if I need to give anybody else advice. So we could have discussions and stuff, but advice too. This doesn't need to necessarily be all about math all the time. I'm pretty sure you'd be bored after a while. You gotta have a little fun, right? Okay. Okay. So let's go ahead and do the next problem here. We're gonna do the next problem here. So let's look at number. Which one am I gonna do? Here we go. Let's look at 21. All right. 21's a very important problem here. Yeah, you gotta have fun while you're teaching and while you're doing a class. Otherwise, why bother taking a class? You might as well bust out a pillow and just start sleeping at your desk. I mean, shoot. Um, suppose you budgeted 2,800 bucks for fuel expenses for the year. How many miles could you drive if gas were 270 per gallon and your vehicle averaged 28 miles per gallon? How would we figure that one out? What would you do? Let's go through this two-step problem here. Wow, thanks for the 100 bits. That's really kind of you. That's really really kind of you. I don't deserve the 100 bits, but yeah, thank you so much, Shaq. So what you guys got for me? 2,800 bucks for fuel, 270 per gallon, and my vehicle averages 28 per gallon. Yeah, I know I don't ask. I don't really ask for donations unless you want to. I don't want to force that on people. I'm not. You know, I make I make good money as it is doing this, so I'm plenty happy. But I still thank you for your generosity. Yeah, so we got 2,800 divided by 270. I agree with that. Oh man, you don't have to give me another, man. Shoot. Oh goodness, I don't deserve any of this. Just doing what I love. All right, so we got 2,800 divided by 270. Uh, what do we get here? We got 2,800 divided by 270. What do we get? I'm trying too hard. Yeah, it'll hear from me soon. No problem. All right, 1,037.04 is what we got there. Okay, fair enough. All right. Uh, oh, 037. Okay, you just put it up to 04 after rounding it. Okay, to 2. Okay. Yeah, both are okay. That's fine. All right. Now take that and multiply it by. What are we going to multiply that by? All right, multiply by 28. Spot on. That looks pretty darn terrible. Let's try that again. How do you make a time symbol? Not like that. All right. Times 28. All right. And what do we get here? 29,037 miles. Okay, sounds good. Nice job. I don't know if I've ever driven 29,000 miles in a year. That's quite a bit. Though, then again, if you have a car that has better gas mileage, that's actually better for you in the long run. So, honestly, though, I haven't driven too much this year, obviously. So, I think a lot of people haven't. So, do I have a drawing tablet? No, I don't. I kind of use a combination of a few things. Yeah, you're right. That could make whiteboarding a bit easier. So I use a combination of this, and I use Word because sometimes I need to put. Sometimes I have certain documents that actually have questions, or I just put it on formatting. And then attached to Word here, Visual, I actually have MathType, which can automatically format into typing for mathematics specifically. So if I wanted to write in, say, something with a square root, then it's a lot nicer to see here when you put like 6x squared, minus 7 or something to that effect. It's very, very handy. My handwriting isn't the best, mind you, that's true, but I try and limit it as much as I can. Yeah, you should. Yeah, built-in latex as well. I'm not a big fan of latex. I tried using latex when I was a grad student. I wasn't a big fan. I actually preferred MathType when I used it back then when I wrote my thesis. So I'm just more comfortable with it than latex. But the latex is really good too if you're good with it. So I'm not going to deny that. I just found it easier with MathType. That's all. So I used kind of three things at once, and it makes things a bit easier. Alrighty. I'm gonna kind of skip this here. Okay. Alrighty. Okay. All right. Any questions about word problems? I know we've been pretty much this whole semester has been all about word problems all the time. So you guys should be pretty comfortable, hopefully, in picking up keywords and kind of knowing what the steps will need to be in order to solve for those word problems. You even saw on the test that I gave last week was all about word problems. So yeah, you guys should be pretty comfortable with that to some capacity. No questions? Okay. So one of the things I like visual, and I think a lot of the other guys in this will agree, is one of the reasons why I use Twitch over Zoom was because I think everybody in the class likes the anonymity with Twitch over Zoom. Like they don't need to like necessarily have a webcam or anything like that. And if they need to go do something, they can go do something without worrying about it. Plus the replays are amazing. If we're talking about if we're talking about replay value, it's really good for replay value. You can rewatch streams and upload to YouTube and stuff like that. So, I mean, that was the biggest reason why I wanted to do Twitch. It was like my first choice. I said I feel Zoom's a little too corporate. Yeah, exactly. Yeah. You gave away your old stove. Oh man. Respect. Respect, Ivan. Um that yeah, I that's the advantage. Like you can rewatch the replays and you can talk to me, just not having to worry, about you looking bad, or you could just sit comfortably in your house and I don't need to see what's going on in your house and stuff. Nice, yes. It it's it definitely offers those advantages, and I hope you take that feedback. You can present that to your superiors there, and then I think they'll certainly like that as well, as that you can offer a good alternative to Zoom, just for that reason alone. When's the test for the 16-week course? That is going to be in about 2.5, 3 weeks from now. So yeah, 2.5, maybe 2.5 weeks from now. I'll make that announcement like a week before that'll be due. So yeah, but it's not gonna be. I'll open the test here in like maybe 2 weeks or so. I'll let you know though, Diego. So okay, yeah. So I don't mind. Yeah, that should be just fine. Okay, what are we doing? Oh, we're doing that. Okay. Yeah, man. Of course, it's all good. I'm just happy that you, Bijou, were able to come down to my little corner of Twitch. I really appreciate that very much. Alrighty. Oh, that's great, man. I'm happy to hear that. Unfortunately, there are no participation points for this class, but you do get some great memes. And let me tell you, Gustavo, memes are dreams. We can make it happen. Okay, next. Let me erase this here. Next. Next, we're going to go and start with Chapter 8. Okay, Chapter 8. All right, so I'm going to go to page 541 here. In Chapter 8, we'll start off with a few things here regarding degree measurement. Okay, so degree measurement. We're going to talk about certain things here in degree measurement, as we're going to be using degrees for solving for triangles later on. We'll also take a look here at how we can figure out the degree measure of, say, a certain object. All right, given knowing the other ones here. Uh, so there are a few things that we do need to go over here regarding angle measurements. So let's go ahead and talk about that right now. All right. All right, let's see what we get here. I mean, if you want to learn something, let's see. Well, what can I do? Right. So I'm going to ask you a personal question, Bijou. Where do you live right now, if I may ask? I'm just, if you don't want to answer, I could totally understand that. You live in Seattle. Okay, perfect. All right. Okay. So have all right. So I'm sure in Seattle, maybe you go out every once in a while and you go out to a grocery store, right? How many Everybody in this chat has been to a grocery store at least once in their life. If they haven't, I don't know what rocks there are that you've lived under, but I know that everybody's at least gone to a grocery store, right? If I told you guys that the grocery store was the pinnacle quintessential mathematical concept, then I'm pretty sure maybe you would believe me if I told you that basically the grocery store is a gigantic probability experiment completely designed to get you to spend more than what you intended. So, for example, okay, I'll ask everybody in the chat, have you ever walked out of a grocery store buying more stuff than what you wanted to than what you wanted to? So it's like, oh, I want to spend like 10 bucks worth of stuff, but then you walk out with 50 bucks worth of stuff. Has that ever happened to you? 100% of the time. Container Store does that too. Fair enough. Yes. All right. So let's think of it this way. The question is why does that happen? Sometimes you have an urge, sometimes you have an impulse. But the real question behind that is why do you have that urge or why do you have that impulse? Well, let's talk about it. Let's say if you go to a Jewel, okay, a Jewel is a local grocery store here. So, or Albertsons owns Jewel, but let's say you go to the grocery store. Now, the first thing that I see in a Jewel or any grocery store is I may see in front of me, I may see in front of me, I may see Chewy Chips Ahoy. I may see, I may see a 12 pack of Coke, or I may see nacho cheese Doritos. Maybe that's the first thing that I see when I walk in through those automatic doors. Okay. Now, the question is, why would I put those items in the very front? Why? Why would I do that? What do you guys think? What's in common between Chewy Chips Ahoy? Okay, what's in common between Chewy Chips Ahoy, Coca-Cola, and Doritos? Nacho cheese Doritos specifically. What do you think it's in common between those three items? That's right. The answer is definitely, Ivan, you got it right on the nose. They are all packaged with the color red. That's right. And when you walk into a store and you see the color red, psychologically, it basically has you on impulse. It's basically right. Red is an impulse color. Okay, red by color therapy and this stuff. And people say I don't believe that stuff. I'm like, no. It basically designs like, oh, it kind of shifts you into impulse mode because red is an impulse color. It gives you idea in your head, like, oh, I should just go grab maybe not that item, but other items. It gives you that first inkling once you walk in the door that it gives you that idea. The first thing I do when you walk in is sometimes you go to the produce section. That's why it's all the way on the left. You say, I'm going to grab this, that, and the other thing. Maybe I'm going to grab the basics. Or again, maybe you walk on the right side of the store and you're like, oh, there's all the booze and stuff. I need to grab some booze. And of course, you got to grab some chips. You got to grab a bunch of other stuff. And it's like, now you spent a lot more than what you had bargained for. They have already gotten you right when you walked in the door. That's just the first part. Then think about locations of items. Certain locations of items are found in certain specific places. Okay, so take the Container Store, as Bijou had asked. Well, certain things at the Container Store, like say on clearance items or on sale, are tucked away in the back a little bit further than you would for the new items in the Container Store, right? Therefore, you would have to go through those particular items, those particular areas, in order for you to go ahead and find the actual items that are on sale. All right, so you have to go digging before you actually get there. And probably before you get to the sale items, you've already seen the very nice items and you start picking it up and start taking it home. And then maybe you looked at the few sale items, but in reality, you already made those decisions prior to even getting to that section. So they'll do that for retail, for clothes especially. All the clearance items, all that stuff. Yeah, all that stuff, it all goes in the back. So that way it forces you to look through every single new item. And if they know they can bank on you just taking every single item there, you know what? They got a winner. Now the question is, here's the bigger question, right? Because there's a question behind this question. It's like, okay, you say I'm already bankrupt before I get to sales. Well, how do I know where they put those items? How do you know what's the best, you know, um, arrangement of items in a grocery store or even the Container Store? Well, if you take a look up The only thing that's up on any store is the cameras. Now, of course, cameras are there for loss prevention, okay? You try to stop people from stealing stuff, and that makes perfect sense. But there's a second hidden thing that the cameras certainly do more than loss prevention. Nobody cares that you lose a Wiener Schnitzel. Okay, nobody cares in a grocery store. They lose a $5 Wiener Schnitzel, they're like, okay, whatever. It's a $5 loss, no big deal. I made a lot more money off the guy who spent 50 bucks more. No problem. But those cameras also look at the probability of you selecting the item in that specific area in that specific location. And they map out these mathematical algorithms and probabilities based on what they see in the cameras. That's the secondary use of the cameras in the store itself. Yes, again, you're trying to protect merchandise, but more importantly, you're watching shopper behavior patterns. And so, based on that shopper behavior patterns within the store, you place the new or select items that you feel that you want to sell out of your inventory in those select places because there's a higher likelihood that you're going to go ahead and grab those items in those particular areas of the store. And thus, you're going to maximize your profit as a result. That is what mathematics does. That is how basically grocery stores or things like the Container Store or other retail stores maximize the amount that they actually sell within the store. And that's how math can be very well can be used against you, but it's reality. That's how most stores will operate on a retail basis. Is basically use all these algorithms to basically set it up in such a way where you're always going to be kind of wanting to reach and grab that item in that particular area because it's new or it's shiny or it fits your style, whatever the case may be. But that's all done by mathematics, entirely done so by probability. It's like putting candy on the very bottom aisle of a, so like candy putting it on the very bottom aisle, for kids to grab. Or think of Chewy Chips Ahoy. Chewy Chips Ahoy is on the center of the grocery store aisle. You know what's interesting about Chewy Chips Ahoy, right? Here, let me show you how math. Let me show how math and cultures come together. This is how it is. You've all seen store shelves, right? People usually say the cheapest stuff is on the bottom shelf. That's pretty true. But let's take Chewy Chips Ahoy for example. Now, Nabisco, the company that makes Chewy Chips Ahoy, pays companies like grocery stores like Jewel millions of dollars, and I do mean millions of dollars, to make sure that their cookies are on the center shelves. Now, it used to be back in the 90s that eye level for shelves used to be up here. This is eye level. So this area was eye level right here. However, in the past 2 decades, the eye level has changed from up here to over here. This is the new eye level. Why do you think that's happened? Why do you think that new eye level has moved one down? That's correct, Ivan. The cell phone in your hand. So as soon as companies figured out that people are staring down at their cell phones and looking one aisle down, suddenly eye level is now shifted one shelf down. And then they saw the probabilities start to improve the more that they start to shift down the products by one of buying that item. And that's adjustments that you can make. So, yeah, there's a math lesson for you about how mathematics can certainly affect you on a daily basis, in one aspect, about just how you shop and how much you spend. It sounds manipulative because it is, but again, it's a tried and true method, so that's why it works. Any questions? Any questions before I guess I move on to chapter 8? I'm gonna eventually get there. been a little slow roll today, but you asked the question about where it's went to Jewel, you needed a creamer, bought water, soda, and Cheetos cheddar popcorn. Fair enough. What did you want to get at Jewel was the question, Ivan. Just the creamer? Yeah, exactly. 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 Yeah, but ask yourself this question, Gustavo. Did you need it? Did you need Cheetos cheddar popcorn? I mean, I understand you gotta splurge every once in a while. That's cool. But did you need it? It's like doing 2 for $6, right? If you get 2 for $6, did you need the second one? Or could you have saved like the $2.70? Like let's say the regular price is $3.30. Did you need to spend an extra $2.70 on something you didn't need? Right? That's the question you have to ask yourself. You're battling yourself. You're like, oh, it's 2 for $6. I got such a great deal. You get $3 each. And one package is like $3.30. It's like, oh my gosh, I'm saving, 60 cents. But then you end up spending $2.70 more to save those 60 cents. And you're like, yeah, I'm gonna have to rethink that. It's the same thing with like buy one get one. Do you need like extra? Do you need more? Is it that necessary? Is it go like sit in your pantry for like 10 years before you actually use it? All right, let's get back to work here. We got it. How about we just do this section and we'll restart here at section 8.2 once we're done here. So yeah, because those go together. So yeah, that'll be fine. All right. 8 gallons a day. Yeah, if you bought 8, that's right. Minimum of minimum of 8. All right. Now, if that was for gas, I'd be like, cool. But if that's not, then no. So let's talk about angle measurement here in this section. Now, angles can be expressed in many different ways. There's many different types of angles, as we'll talk about in here. So let's take a look here at some things regarding angle measurements. So we'll first talk about the major angles here. So major angles that you'll see here quite often, we'll go over the first one here. The first one here you've probably seen many times over. So the first one here is a right angle. So right angle is equal to, again, this is equal to straight up 90 degrees. All right, so that shouldn't be too hard to figure out. Okay, now based on 90 degrees, there are two more other types of angles that are fairly common. So first one here is this angle here. This is an acute angle. So an acute angle here is, again, going to be less than 90 degrees. So less than 90 degrees here will be an acute angle. The opposite of that is this dude. And this is an obtuse angle. So an obtuse angle here is bigger than 90 degrees. So we're just using that metric there, bigger than 90. We also have this right here. This is an angle. Although it looks like a line, we do have an angle here. This is a straight angle. So straight angle is straight up 180 degrees. Okay, no problem. All right, pretty easy. Okay, pretty straightforward. Ha ha ha. Terrible puns. All right. Um, A couple other things regarding angles that we need to talk about here is that for triangles, okay, let's talk about triangles here. All right. So triangles, first and foremost here, the sum of the interior angles of a triangle sum of the interior of a triangle here is going to be equal to 180. Okay, so that's specifically made for triangles. I only mention this because we'll see triangles in a lot more detail for the very last chapter talking about trigonometry, so we obviously have to go over that. So at least we should get used to that concept now rather than later. And then let's see here. We'll talk about this here a little bit later. Yeah, it's a straight angle there. Is there? Let me check to see if there's anything more I really want to say on that fact. There's certain things that we'll talk about here. There's certain things that don't need to. Okay. And so we go again. Triangle. Sum of interior equals 180. Circle. Again, angle is 360. Okay, so as you know here, 360 degrees is going to be equal to a circle. Now, one of the things we'll actually talk about here in chapter 9 is we're also maybe chapter, yeah, no, it's chapter 10, I should say, apologies. Chapter 10 is we're going to talk about another way to express degrees because we do need that for trigonometry. So we'll talk about the other way we can express degrees here as well. Now, for what we're going to be doing here in this particular case is we'll look at several examples here, first and foremost, to determine how we can find the remaining angle measure. Again, in this section here, that sometimes some questions will ask you to use a protractor. In reality, if you're in the trades, then it makes more sense to use something electronic as your protractor. Obviously, a hand one is not good enough here in the shop since you need maximum accuracy and precision. That's very, very important. So since you need that specifically, you're going to use all types of equipment here, such as a projector, a microscopic, like say, projector that can show you the piece and give you the dimensions and the angles and everything like that. So there's going to be certain things that certainly you'll have in a shop, which will make things significantly easier at the end of the day. Uh, get to this here in a second. Okay, now let's go ahead and do some examples here. Some of these aren't too hard, but we'll take a look and see how this works out. So won't be too bad, I promise you that. Okay, let's look at letter B. Okay, so we want to determine what D, E, and F are going to be. All right, so this concept here in letter B uses what we call congruence. Congruence is just a super fancy word for being equal. All right, so this is basically when one side has an equal angle measure to another. Okay, so that's basically congruence. In this case, if you take a look here at letter B, we have 16 degrees here, okay, and we have 16 degrees right here. E would be equal to 16 degrees because this side is congruent to this side. This is what we call a parallel angle here. But so E here would be equal to 16. Now let's go ahead and write that down here. Where are you? Okay. Okay. Now, can anybody tell me, looking carefully here, this one's a little tricky, I'll admit. I'll admit this. It's a little tricky. It's not easy to see. Can anybody tell me what D would be equal to? What would D be equal to here in this case? What would D be equal to? 164. Okay. And how did we get 164? So I'll agree with you, Ivan. That's correct. 164 is correct. 180 minus 16, correct. Very good. So the trick here behind this particular problem is, yeah, the trick behind this is that noticing that this is just a line. So if we're taking the angle here between D and 16, that is a straight angle. So that's going to be 180 degrees just between these two angles alone. So we take 180 minus 16, absolutely correct here. And so that's how we get 164, right? And so by virtue, F is also going to equal 164 because it's congruent to D. So now we're not going to focus on congruency and stuff in this class all that much, but I'm just pointing out here certain aspects that'll make you find some of the angles a bit faster. Okay, so not doing things that are too tough. It's just like, here it is, here you go. Okay, let's do another one here real fast. Let's look at letter F. What would our missing angle be here in letter F? So we got 100, we got 27. What would be our last remaining angle there? So I got 100, I got 27. What's this last angle that we're missing? 53. All right, great. That's right. So again here in this particular instance, let's go back to our little Word document. All right, so here we're going to have, again, 180 degrees. Again, we do know for a fact that triangles are always going to have 180 degrees at that equal to. So we're going to 180 minus 100 minus 27. And then we get 53 degrees as our answer for that. Okay, questions so far? Okay, now there is one more thing in here that does pop up later in this chapter and in subsequent chapters. So we're going to go ahead and do letter I here. Okay, we want to find this degree measure here. Okay, but the thing is, in this case, we're given a degree measure, but this time it's written very differently. We're given here in degrees and minutes. Okay, that's what these are. So what we're going to do here is I'm going to kind of expand a bit. Oh, do I need? Oh, you're right. Thanks, Bijou. Appreciate that. It's a little hard with this guy. All right, there we go. Now we got it. All right, that should be helpful then. Yeah, got it. All right. Thank you, sir. All right. Okay. So here we have 73 degrees 46 minutes, and we have 46 degrees 12 minutes. Now I'm going to expand on this just a little bit because again, this is one of those things that if you're going for even further precision and accuracy and stuff, you're going to need to know not just degrees and minutes, but you may need to know degrees, minutes, and seconds. So that's what we're going to talk about here, is how to approach either adding degrees, minutes, and seconds and subtracting degrees, minutes, and seconds, okay? And so we're going to talk about that in some detail right now. Okay. Now, let's talk about some of the basics here with degrees, minutes, and seconds. Now, the initial concept here is not hard. Okay, it's actually fairly straightforward and fairly easy. All you need to know here is that specifically we'll say 60 minutes is equal to 1 degree. Okay, so let me get that here. Oh, that should be in there we go. All right, so 60 minutes is equal to 1 degree. And just like regular time, which isn't too hard, again, 60 seconds 60 seconds is going to equal 1 minute. Okay, so by and large, again, just like time, it's really not too hard to figure out exactly how those conversions will go. All right, fairly straightforward there. However, we do also have we also will look at a little bit later on, not in this section, but we'll also see decimal degrees, and we sometimes might want to convert them back into degrees, minutes, and seconds. So I'll state this for that purpose. We're not going to use it in this section per se, but we're going to definitely use it in a future section. So what's that going to be? Essentially, it's going to look something like this. We have specifically here 1/60th. So 1/60th of a degree equals 1 minute. And this conversion here is very helpful for converting into decimal degrees. So that's why we're kind of stating this here. And then we have gotta put that down. And then using the conversions we have over here, we have 1/3600th of a degree equals 1 second. So like I said, we're not gonna do both of these. We're not going to use these technically right now, but in a future section, yes, definitely will be helpful. So at least having the information on hand will be helpful for you. All right, let me move this down. Okay. So the primary two we're going to use is the 60 minutes, 60 minutes, 60 seconds sort of deal. But let's go over an example, and let's take a look on how we can either add or subtract degrees, minutes, and seconds. Okay. All right. So let's go over addition first, okay? So let's go over addition first. Addition is actually pretty simple for degrees, minutes, and seconds. So fortunately for us, this isn't too bad. So I'm just going to write down two random degree measures. We'll add them together, and let's see what we get. So let's say we have 39 degrees, 45 minutes, and let's say 23 seconds. And we're going to add that to 27 degrees, 18 minutes, and 52 seconds. Okay, so we're just going to add these together just like so. Okay, so the first thing that we're going to do here to add degree, minutes, and seconds together here is we're just going to add pretty much straight up. Okay, so that's all we're going to do is add straight up. So I'm going to take 23, I'm going to add it to 52. Okay, just doing like regular addition. So here I get 75, and this is 75 seconds. I get 45 plus 18, which is 63 minutes. And then 39 plus 27, which is 66 degrees. Okay, so I've just went ahead and just added each one of the respective things over. Not too bad, straightforward, good beans and rice. Okay, now what we need to do here is now we need to convert anything over 60 minutes or 60 seconds. Okay, so that's the key here, is to convert. If I can spell, let me know. It's pretty bad. All right, so okay. So we're going to convert anything over 60 minutes or 60 seconds because we're going to use those two conversions, and we want to see, how much we need to add for degrees and all that jazz. So that's what we want to do essentially. So for example here, It's pretty easy for time, of course, 60 seconds. Here, we just basically take away 60 seconds. That's going to be 1 minute, all right, and 15 seconds. All right, now the thing you need to be careful about is we're not working with hours, minutes, and seconds. We're working with degrees, minutes, and seconds. So converting 63 minutes is going to be 1 degree and 3 minutes. And now we're just going to add each of these straight up with each other, and we're going to get our answer. So we have 66 degrees plus 1 degree. Well, that's 67 degrees. So 67 degrees. 3 minutes plus 1 minute is 4 minutes. And 15 seconds. So there we go. We've effectively done the addition there. The addition is very, very nice and straightforward since you're mostly working with time-based things, so it shouldn't be too hard to do. But that's addition. Are there any questions about that before we move to subtraction? No? Okay. Okay. Now, what about subtraction? How does that work? Okay. What is subtraction going to do? Okay, let's look over subtraction and let's see what we're working with here. Oh, I didn't mean to do that. Okay. No. Okay. Okay. So subtraction between degrees, minutes, and seconds is by far very different than that of addition. You have to be very aware about what stuff you're kind of moving around. So let's talk about what we need to do here. You just need to be a little bit extra careful, but once you are, it actually doesn't turn out to be too bad. So let's do 180 degrees straight up, 180. So I'm just going to put, again, 0 minutes and 0 seconds. Now there is a reason why I'm putting this in, even though I know it's redundant. I know it's completely redundant, but I have a reason for putting that in there. But we're going to see how we can tackle it with this tough one. So, all right, so this one here is going to be 60. Let's go with 63 degrees, 49 minutes, and 18 seconds. Okay. Now, unlike what we could do for the last example where we could just add it straight up and then convert it over, unfortunately, we're not given that option here. It's kind of out of our purview. We want to change it into something that's easier, but right now, as it stands, it's not. Now, you know what would be easy? Like we did for addition here, we could again add 23 and 52 or whatever straight up. I said it would be significantly easier if the number on the very top right here would be bigger than the number below it. And the question is, well, how do I ensure that that happens? Well, that happens to be the key here to the subtraction. The key here is that we're going to borrow, we're going to effectively borrow 1 degree or 1 minute. So let me describe what's going on here. Okay. So the thing is that I have 0 over 49, not really all that doable. I got 0 over 18, not really all that doable either. But what I can do is I can borrow, effectively I can borrow 1 degree from the 180 degrees that I have over here to the left. So if I borrow 1 degree, one thing we know about 1 degree here is we know that 1 degree is equal to 60 minutes. So let's rewrite it the first time before we do anything. I'm going to borrow 1 degree from the 180. So now I can rewrite it like this. I can rewrite the same problem as 179 degrees, 60 minutes, and 0 seconds. And I just keep that bottom part the same. Okay. Now, obviously, that's not good enough because we still need a number that's bigger than 18 to be here in the second spot. So what we're going to do here is we no longer need to borrow 1 degree, but we can borrow 1 minute because we know that 1 minute is equal to 60 seconds. So we can rewrite this as, one more time, one more rewrite, as 179 degrees, 59 seconds, 59 minutes, pardon me, and 60 seconds. And we'll subtract that from the 63 degrees, 49 minutes, and 18 seconds. Okay? Now, as you can see here, every number that you see is now on the top is now bigger than the number on the bottom. And now we could just go ahead and do what we did for addition. In this case, though, we're just going to subtract straight up, and we're going to get our final answer. So the trick for this is just to rewrite it a couple times or maybe once, and then go ahead and do the subtraction as necessary. So in this case here, we have 42 minutes. Here we get 42 seconds, sorry. 10 minutes, and 179 minus 63 is 116. So 116 degrees, 10 minutes, and 42 seconds. Any questions about that? So we will see more of degrees, minutes, and seconds later on as we continue in this chapter, in the next chapter. So you'll definitely see that again for sure. Okay. Now, unfortunately for us here in this particular section, there are not many good word problems. There are very few because they ask you to use they actually use, some of them ask you to use a protractor. So the word problems in here aren't the greatest just because of that fact. But what we can do here is at least figure out one of them. So one of them actually has a good relevancy to it. So let's take a look at that one. Alrighty. Okay. So let's take a look at number 13. So 13 is probably the best problem. So there's not a lot of good ones here in this section, sadly. So 13, welding. In the pipe flange shown, the 6 bolt holes are equally spaced. What is the spacing of the holes in degrees? What do you think we get here? So the 6 bolt holes are equally spaced. 42 is the meaning of life, but sadly, not the answer to this question. 60. Okay, 60 Fegrees. 60 Febreze. No, I'm just kidding. 60 degrees. Yes. 60 degrees is correct, right? So you have a circle here. This circle here is 360, since you know every circle is 360. And since they're equally spaced, every 6 of the bolt holes, that's going to be 360 divided by 6 is 60 degrees straight up. Okay. All right, so that's how we can go ahead and find out that guy right there. And that's probably the best one because the other ones, imagine, you got to ask the great calculator. Today was just doing some angle measures and some other algebra stuff, my friend. So just letting you know. All right. So we got 6 bolt holes equally spaced. Yes. Okay. So yep, 360 degrees. So we're going to be looking at more problems here using degrees, minutes, and seconds in some capacity. Later on, we're going to look at also perimeter and area. Okay. Um. Hi, Chris. You guys got lost an hour ago. Hey, I've been trying to explain things properly. Well, Well, fortunately, I'm back on track, and there's a replay of this because, yeah, because I love replays. All right, so thanks, Chris, for the follow. I appreciate you. Um, you guys still don't get too focused on one thing. Don't worry about it. Don't worry about it. Okay, no worries. Okay, gotta focus. Eyes on the prize here. Knowledge. Come on, let's go. All right. All right. All right. So, there are any questions from chapter 8? I should say section 8.1. So, what week are we doing plane conic intersections? Yeah, unfortunately, this is not the class for it. Holy moly. That's way over my head these days. I haven't done that stuff in, 20 plus years. Today we did a little bit of algebra there, Chris, and we're doing angle measures here, just the introductions. And next time we're gonna go over perimeter and area of some quadrilaterals. So that's what we're doing there. No problem. Man, everybody's coming out tonight. Jeez, everybody's out tonight. Logician's back too. There you go. How you doing, buddy? This is what I like. I like being in the nice corner of Twitch. You guys make it worthwhile. I really appreciate you guys very much. Much respect. Any questions at all, you guys? You guys can ask me whatever you want, so it's fine. You guys feel free to ask me whatever you like, so I'll be happy to answer for you. How tall am I? That's a great question. Um, that is a wonderful question. How tall am I? I'm 5'10". 5'10" is what I. Quadrilaterals are basically 2D shapes that have four sides, but not of equal value. Muscle groups. Let's see here. Hang on. I need to move back a bit for this. To answer your question here. Non-existent pecs. Um, Very flabby deltoids. Pretty bad. Calves that probably have the tone of butter kind of churning in a pan that is slightly getting hot. Uh, Thighs that look like half ice creams. Yeah, that's probably where I'm at. Slightly like Mr. Dursley from Harry Potter, that kind of pudgy pudge. Yeah, that kind of thing. So now I want ice cream. What's my eyesight? That's a great question. My eyesight is terrible. I mean, absolutely awful. So my eyesight here in my right eye is minus 12, and my left eye is minus 12.75. So you always look at the drawings on the top of my closet. Oh, you're talking those. Oh yeah. So those three things are what my mother had given me. My mother is a pretty devout Muslim, so she gave those to me as kind of words of protection. I'm not a religious kind of guy, but I'm not here to talk about that anyway. But in any case, yeah, she just says she wanted me to keep those there, and I love my mother, so I definitely acquiesce to that. So just to keep myself safe, it's her thinking of me, so I appreciate her. I love her, so They're all written in Arabic and whatnot, like very. Do I believe in God? Yes, yes, I do. Just maybe not in the same way that, just maybe not in the same way that you would conventionally think of believing, I suppose. I have my own thoughts on the subject, but one of my rules is one of my very strict rules for myself. And one thing I do is I never tell you guys my beliefs because it's not up to me what your beliefs should be or shouldn't be. No, 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 no. Don't feel insulted. No, no, no. I'm just telling you. Oh, don't feel bad, Gustavo. That's a fair question. I told you I'd answer honestly. That's fine. Um, do you vote for Trump? I mean, honestly, I don't know what to think about the election, to be perfectly honest. I don't like either candidate. Uh, Both are not great because, well, I'll put it this way: you have extremes on one end of the spectrum or the other, and it's you know, like I've said this before, but I'll say this again. Like, I live in the United States of America, and I just feel that we move away from the very first word of the country, which is united, and I feel very sad about that. Like, I wish we were more united. Who's my celebrity crush? Um, Yeah, I want United States, not divided states, not extreme states. I want United States. Who do I think will win? Let's see. Who's my celebrity crush? I don't have a celebrity crush. I don't even watch TV. I only watch TV for AEW wrestling and football and baseball. That's what I watch TV for. I don't even have television in my house. Um, who do I think will win the presidential election? I think it'll be. I think even despite what the polls say right now, the polls don't really reflect what's going on, during election time. I think it'll be awfully close. Right now it looks like Biden. I think it depends on what happens at the debate. You know, um, a lot of people have already made up their mind, so really it comes down to the swing voters. Uh, many of them many of them will probably vote by Biden, but there you can't tell. One of the things that is true, that you have to understand when it comes to voting, Chris, is that not every vote is equal. So that's something that you have to keep in mind. Not every vote is necessarily equal because it depends on where you live. So you have to be a little bit careful, like this person got the most votes, but that's not necessarily true. Yeah, you're fine, Ivan. Yeah, in this electoral college, it's the way things are done here in the country. But you know, like if I live in Illinois, right? And I could tell you right now, uh, I live in Illinois. Does my vote really count? Yes, it does. Just not in the way that you think it does. Because if I live in Illinois and Illinois is a pure blue state, okay, my vote's not going to go for a whole lot because I live in Illinois. My vote does go further for local elections, of course, that's going to go further. But for the presidential election, pretty much not a whole lot. Yeah, state and local are definitely important too. I'm not denying that at all. You should definitely vote for those if you feel very strongly about that. But for the presidential election, it's unfortunate because if you're a Republican in Illinois, you don't get the same voice as Democrats do, and the same thing goes as if you're living in let's say a Republican state like Nebraska, and if you're a Democrat in Nebraska, your state's going to go red anyway. So um, it's just like the matter of voices that are kind of you know the voices are kind of snuffed out because of that fact to select your president. So yeah, that's why it's not so equal. Like Republicans in California, or again, Democrats in Oklahoma. All right, there's states that are always going to be dead red or dead blue. They're always going to be that way. So I'm just wishing for, equal voices when you make that vote, as equal as they are for state and local elections. So I think those are just as important, regardless of which side of the aisle that you're on. Can I try a British accent? Let's see. Welcome everyone to another episode of Hashtag United. All right, there. There. Let's. This is my terrible British accent. uh, I love Hashtag United, so can't really fault that. What field of mathematics do I find most interesting? It's always been algebra. Algebra's kind of been my thing. So algebra is really fun. That was amazing. Oh my gosh. I'm definitely not British, not by a long shot. I got the pure Midwestern accent that basically is no accent. So, though every once in a while, for some reason, people have told me I slip into Southern drawl. I'm not sure how that happens, but okay. Can I buy you a Tesla? No, but you can buy Tesla stock. That would be great. Or you can buy Tesla options. That could be okay too. Of course, you'll need to get some more information about how to do that, but it's possible. If you ever want to buy a stock that's worth it in the long run, Tesla will be worth it in the long run. There's enough fundamentals behind Tesla to know that they're going to be a very big company 3 to 5 years from now, even bigger than they already are. You guys got any other questions? Again, the forum is open, so pizza party. Pizza party. Hmm. I think pizza party does sound like a good idea. Pizza party does sound like a good idea, or at least go to the steakhouse and just have like a nice big steak. Yeah, pizza party does sound like a good idea. Get some uh, get some Lou Malnati's there. Is that it for today? Yes. You're free to go if you like. We're done for here for the day. We're going to restart here at section 8.2. So if you need to go, or you want to log off, please feel free. I will see you back on Wednesday if you're going to leave. So I don't. No. I'm not leaving just yet. If you have more questions for me, Bijou, please feel free to ask, my friend. I don't mind what you ask me. It's all good. I'm glad you had a lot of fun, though, my friend. I hope you have a wonderful rest of your day out in the West Coast there. Did anyone make a Discord for the course? I don't think so. I don't think so. What do I think about Elon? I think Elon is very uh I think Elon has a lot of really good ideas. He's kind of looking forward. Um I will say Elon is not the greatest in terms, like he'll make a lot of declarations, which certainly idealized sounds really good. It just takes him a while to get to that ideal. So it's like he's very eccentric like that, but I can respect him for it because he actually puts it out. It just people want it now, 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 but Elon's like, no, we take our time, being realistic. You know, he's very good at that. So I like Elon. I think he's a really good leader. I think he does believe it, and that's the one thing why you like Elon, because Elon really believes what he's actually saying, and he follows through with it. I think that's the one thing why I like Elon so much, is that it's not just a guy just saying stuff and just providing nothing. It's somebody who actually believes it and then actually takes the action to go through with it. And that's what I respect about Elon the most. Good night, Diego. You have a wonderful night, okay? You take care of yourself. We'll see you on Wednesday. You guys got any other questions? You can ask away if you like. All right. All right, Ivan. We'll see you on Wednesday, okay, buddy? Yeah, you have a good one, my friend. Put a little more sanitizer. Okay. No problem. I'll be here. Feel free to email me if you have any questions, okay? All right, Gustavo, you have a wonderful night, okay? Take care of yourself. Anyone else? Miguel, have a great one, okay? Please have a wonderful night. Anybody else? Well, can't think of anything? That's fine. I don't mind. That's perfectly okay. Nothing really that I'm gonna trust me. There's a lot of things we could talk about, but that's okay. You may well, you know something about me. Maybe not a lot, but some. I have different views on different things. But I'd like to say that, like I said, I just want to be that guy that Um, I may not be the entertainer totally, but I like to have fun while learning something here, and I think that's just as important, especially on this platform. So, um, I hope that the one thing that like I said, I genuinely hope is that I hope you know a little bit more than you came into this stream with, and it could be a minuscule percentage, like so tiny it could fit on a pin, but if you know just that little bit more, that's all that matters. That's all that matters. Hey, I try to give the best type of quality stream. Everybody's got a different opinion of what a quality stream is or good quality, but I do thank you for that. It's very kind of you to say. I'm glad that at least for you that's helping you out at what time is it now over there in Germany? Is it like 3 in the morning or 4 in the morning? I know it's early in the morning when you come on, so for you. Oh, I know you don't. 2:28 a.m. It's close. It's close. You may not have to learn that stuff anymore, but like I said, the practicality behind math is still there. It's still there, and it's still useful in some form or fashion. And even if it's not math, even if it's just random stuff that we talk about and you learn something off of that, then that's just as cool. I'm down with that. All right. Well, this is where I guess this is where we'll stop here for today. I want to thank everybody who came out here today. I appreciate all your time and all your energy to even come out and listen to a guy like me. It's very nice and kind to meet all of you here tonight, and I hope to see you all on my stream tomorrow or Wednesday or later on in the week. Okay, everyone, have yourself a wonderful night. Please take care of yourself. All right, and have a good one. Stay safe, stay healthy, everybody. Take care. All right, bye.